Welcome back, Algebra Express. We are in Marecek 6.2 today. So today is going to be an epic day. We are doing factoring trinomials. So like I've said, this course builds on itself. So if you don't know how to do this, there's going to be a lot of sections subsequently that are going to be really difficult to do. So like I said, if you feel lost, make sure you are understanding this while we're getting through it. It is going to come up and it is going to come up again and again. And so this is a big part of this course. So sorry to put so much emphasis on it. It is doable and you can do this. It's like a big puzzle. Look at them. It's puzzle time. So this is called factoring trinomials using the AC method. You'll see why we call it the AC method in a second. So they are trying to give us this. So what I want to say is their little X here is okay. Personally, when I do it, if I want to multiply to 24, I do a little factor tree with 24. Like it says it wants to add to. So I will write that off onto the side. So for the factor tree, I always start with one. I don't do every single factor. I just kind of go up one by one. So I go from 1 to 2, 12, 8, 46. 5 is not going to divide evenly into 24. And then once we're back at 6, we've wrapped around, so we've done all the factors. So if you want to do all your factors, this is sort of a really easy way to get at them. So if we want two numbers that multiply to 24 and add to 11, we can look over here, we can look across, but the two numbers that we're looking for are 3 and 8. So if we multiply 3 and 8, they will multiply to 24, they will add to 11. There's another sort of thing we might want to keep in mind. Two positives will make a positive, but also all these things they could have also been negatives, both of them. But here's the thing, if they're both negative, all these are going to sum to negative numbers if we look at them. So we knew the sum was positive. So sometimes we can keep these sort of things in the back of our mind, like this is a possibility. But we don't always need to write everything out. If we know it's going to add to a positive number, sometimes we can skip a few of these steps, right? So the numbers I was looking for are 3 and 8. Okay. Now we want a negative 27. Multiply to negative 27 and add to 6. So if I'm thinking about just 27, it's going to be 1 and 27 and 3. Thinking about the number not the sign, it will give me something like 1 and 27, 3 and 9. So for it to be negative, even so now we're looking across. This is going to add to what? 27 and a minus 1 is giving me 26. This one will add to 6. If we look here, this one is going to be a minus 6. So this one will not work because it's a negative. We want the positive. This one is the one we want. So not that one. So minus 3 and 9 will multiply to minus 27. And when we add them, they will add to 6. Okay, so now we're looking at this thing, the AC or grouping method for it. something. So this is something in standard form. We have something that ax squared plus bx plus c. So this is a quadratic. It's not an equation. Expression in standard form. So there's a coefficient on an x squared, there's a coefficient on an x, and then there's some sort of constant, just like right here. So the a here would be this first thing on your x squared. Your b is the thing on your x, which is the 11, so just the coefficient. And then the last thing here is c, which is and so if I want to do this, I want to factor this polynomial using the AC method, or more specifically, it is a quadratic. And so the AC method says we take a times c, which is 6 times 3. And my b is the other thing here, positive 11. So now we're looking for two things. I don't like doing their little X thing. After they quit putting them on the paper, we'll even quit talking about them. But here's 4 is not going to do it. 5 is not going to do it. And we're back at 6. So if I'm looking for two factors of 18 that add to 11, and they can both be positive or they can both be negative, but we know they're going to add to a positive number. So I think it's easier just to sort of look at these two right here. So it should be 2 and 9. And so we're looking at this thing. Oh, they split it page to page. Okay. Coming from the previous page. So this is 18, this is 11. This was my 2 and my 9. And I don't like that they split it because we need to see x squared plus 11x plus 3. So we're starting with this thing. And the approach to the AC method is essentially we're going to take these fancy numbers. We're going to find our fancy numbers 2 and 9. And we're going to split this middle thing, this 11x, we're going to split it up into 2x and 9x. So it might be tempting. These are like terms. If we add them back together, we're going to get back to our original equation. So we want to continue further. We're using the magic numbers that we find to split this thing up. They're going to multiply to AC, and they're going to add to that middle term in B. Middle term part, factor resulting 4 terms by grouping. So this was what we did on the previous assignment. We started with 4 terms. And so the overall sort of approach to the AC is that we're going to break this thing up. We're going to break that middle term up into 2 terms. And now we have 4 terms. We know how to factor 4 terms. And there's a few ways to do it. But I think I'm going to start with doing the box method. So if I do 6x squared, add plus 2x, and add plus 9x, plus now I'm looking. So if I'm looking across here, I see 6 and 2, I can take out 2, and x squared, x to the first, I can take out an x. Looking across here, I have a positive 9 and a positive 3. I can take out a plus 3. So you do want to write the sign when you do the box method. And then the next thing is here, 6 and 9, I can take out 3 between those two things. X squared and x to the first, I can take out an x. Plus between, I can only take out 1. And I can check some numbers, make sure everything's multiplying up. It looks like it should be. It is. Okay, so now we take these two things, this 3x plus 1 and plus 3. So the other way you could do this is factor by grouping. So if you group the first two and you want to group the last two, it is the same as the box method. So the box method is just taking place of factor by grouping. It just helps to organize things a little bit better for some people. So whichever way works for you, go for it. I'm giving you sort of two different ways to do things. And so if the box method doesn't make sense, I hope you're following along and doing the factor by grouping, and vice versa, right? If the factor by grouping doesn't make sense, do the box method. This usually gives people more structure, so if it feels like something that you're having difficulty with, I would suggest going with the box method. It typically helps people. So fill in signs. So what are they saying here? They're basically giving us signs and asking us, we have two things that multiply to a positive, and they're going to add to a positive. They would have to both be positive numbers. So in order to multiply to a positive, they're either both positive or they're both negative. If that's the case, then they're going to add to a positive, then they have to both be positive. So now we have the other scenario. If they're both multiplying to a positive and adding to a negative, then they both have to be negative. So they're either both positive, they're both negative, or the other scenario is one is positive, in which case they're going to multiply to a negative. So that's basically what they're trying to get at here. Like I said, I'm not a big fan of their chart, but we'll do a few examples that will get at this sort of principle. So let's do it. Okay, so we want to do the AC method. The first thing I'm going to ask is, what is A? So if I look at A times C, here it's going to be 4 times negative 3. So that would be, I'm not even going to use their little x anymore. I'm just going to go with my approach over here. So I'm looking at negative 12. I'm looking at the factors of negative. And if these things are multiplying to a negative, one's negative, multiplying to AC, they're adding to B, which is a good label on everything. Okay. So we're looking for two things that multiply to AC and add to B. We're looking at multiples of negative 12. So one of these has to be negative, one of them has to be positive. I don't want to keep writing numbers out again and again. So if we're looking at two things that subtract to 4, and if I'm looking here, it would be 6 and 2. And if it's positive 4, it would have to be negative on the 2 and positive 6. So again, we have an option, either all these are negative. I guess I'll go ahead and write this down. 1, 2, 3, 4. The numbers you should be looking at or having in your head. And so if I add these, this is 11, this is 4, this is 1, this is 1, 4. This one would give me negative 4, this one would give me negative 1. And so I want to break this thing apart. So I want to break this thing apart with the box method. So I know x squared goes here, minus 3 goes here. What's going in these two boxes is plus 6. Other thing, it's coming from this middle term. it has to have the same variables in it. So don't forget your variable. Now I'm looking across between 4x squared and minus 2x. I can take out a 2x. Between 6 and minus 3, I can take out a positive 3. The rule is if it leads with a negative, we take out a negative. If it leads with the positive, we take out the positive. And now we're looking here, down here, between 4x squared and 6x, I can take out a 2x. Between minus 2x and minus 3, I can take out a minus. Check my squares. Hopefully, I can see that they multiply through, and it looks like everything multiplies through it checks. And so that is another benefit of doing the box method, is that you can check your solution right quick. It is fairly visible, and we can look at these things and see if we did it correctly. And if we look at this thing, we have a 2x minus 1 and a 2x plus 3 that we're factoring out. Okay, so now we're looking at the next problem. 6x squared minus 1x minus 12. If we do the 8, then it's probably AC because we take 8 times 8. That's giving me 72 out, a negative 72. And the thing that it adds to is going to be minus 1. So I'm looking at factors of 72 that add to minus 1. So I'm looking at 1, 2, so you're just going, so that I think I said this earlier, but you're just going down the row of each number. You start with 1, you go to 2, and you see, if you have a calculator, you can do this really quick. You see if it divides it evenly. 72 divided by 3 is going to give me 24 in the calculator. If it's giving me a decimal or fraction, I can reject it and say it does not divide it, right? It's not a factor. So 4 and 18, 6 and 12, and 8 and 9. And by the time you do 8, you're going to wrap around to 9. So that should be all your factors for 72. Now, for it to be negative, one of these has to be negative, and one of them has to be positive. And they have to have a difference of 1. So we're looking at these. How do we make a negative 1 out of these numbers? And the way you're going to do it is you're going to make the 8 positive and the 9 negative. Okay, and we're going back. Well, let me write 6x squared minus x. That was a minus 12. What we're doing is we're making this. Let's bring it down a little bit. Okay, so remember what we're doing here is we're taking this middle term and we're splitting it apart. Maybe bring it down just a little bit into these two things. So we have a 6x squared. We have a plus 8x. We have a minus 9x. And we have a minus 12. Okay, so we're looking at this. What we're doing is we're grouping here. We're going to group here. And we're going to factor out common factors. So I'm going to do this one factor by grouping, just so we have a little bit of variation in here. So between 6 and 8, I believe I take out 2. I can take out an x between the two x terms. 3x left over. Everything is right. These will align in between minus 9 and minus 12. It leaves with the minus and take out the minus. We got a 3. I believe we're left over 3x. Minus divided by minus is going to become positive 4. And so now I have this thing. And like I said, hopefully these zeros are matching up. We can factor by grouping. We're pulling out the 3x plus 4. And we're going to be left with a 2x minus 3. Okay. So you might notice a little side note. What happens if we swap our variables? The same thing. The same thing. 3x, we're going to look at 3x. Ooh, no, sorry, 2x. I don't know how to multiply 3 into anymore. But here we go. 3x is going to leave me with 2x minus 3. And I'm going to pull out plus 4. And that's going to leave me with 2x minus 3. And as I said, I'm going to pull out 2x minus 3, and that's going to leave me with 3x plus 4. So hopefully if I did this correctly, 2x minus 3 and 3x plus 4. Oh, okay. So what happened? They swapped the order in which they came out. That might be something to know, right? So now we put out the 2x minus 3, and there's the 3x plus 4 left over, versus pulling out the 3x minus 4 and the 2x minus 3. But they are the same factors, right? So let me maybe squish this paper down. We can get both of these things on the same projector. There we go. There's our two factors. And so you might notice they are the same factors. They are just in a different order. And so it's being multiplied. So it doesn't matter what order we multiply these in. So this is the same thing. It is the same solution. Go to this. Okay. There's a similar sort of thing that will happen with the box method, right? When we do the box method, whether we write one of the factors in the top right or the top left, it doesn't really matter what order we write them in the box. So going back to this one, if we swap the order of the box right here with the minus 2x and the plus 6, it's going to swap the order of these factors, but we're still going to get the same two factors. All right, we got to factor a few more things. Going with that one. Oh no. What are we doing here? We want two factors by the AC method. So the AC method, as is in the name, we take the A, we multiply by the C. So if I'm looking at A times C here, so I'm going to start jumping to what A times C is. 6 times a minus 5 will give me a minus 30. So I want to factor a minus 30, and I want that to add to 13. So I'm looking at factors of a minus 30. So I want to look at just the numbers 1 and 30, 2 and 3 and 10. Oh, yeah. 5 and 6 is the next one. 4 is not going to do it. 5 and 6 is back around. We want this to add to a minus 13. So again, either this side is negative or this side is negative. So if it's adding to positive 13, we're going to have to go with 15 and a minus 2. So you might notice we also have 10 and 3 there, but one of them has to be negative, one of them has to be positive. So we have to account for the sign. And if you have to write out these factors twice like I did earlier, go ahead and do that, right? You can write out negatives on this side, you can rewrite out the factors, write all the negatives on that side. If we want them to add to 13, maybe negative 2 and 5, 15, I can't speak anymore. So we're doing x squared. We're going to break that middle term up into x plus 15x. a minus 5. So we started with 6x squared plus 13x minus 5. We split that middle term up into minus 2x plus 15x. So if we add these both back together, minus 2x plus 15, that's going to give us back to this original equation. So that's not where we want to go. Where we want to go is we have 4 terms now. We're factoring. How do you factor 4 terms? Factor by grouping them. So I'll do another factor by grouping, and then I'll probably jump back to the box. This and I want 3x minus 1, and I'm left with a 2x plus 5. Okay. The next problem looks like 6x squared minus 13x plus 5. So if we look at this, a times c is 6 times 5 is going to give me, looking at factors of 30 that add to minus 13, which is my b. So the first coefficient times that last constant is the AC. 1 and 30, same factors of 30 that we had last time. The factors of 30 didn't change since I did it. Same factors, throw them down. And this time it is a positive 30. And so they're either both positive or they're both negative. So if they're both positive, we're looking along here. This is going to be 31, 17, 13, 11. They're all going to be positive. We want it to be negative, so they both have to be negative. They're both negative. We're looking here at minus 3 and minus 10 are going to add to minus 13. And so if we're taking this thing and I want to throw it in a box, I know I start with 6x squared. I know it's ending with, where's it? Plus 5. And I know this middle term is the next term. And so this is a minus 3x, and this has to be a minus 10x. So these also have to be x terms. So I'm looking across here between 6 and 3. I'm taking out 3. Between x squared and x, I can take out an x. Here I'm looking at, it's leading with the negative, so take out a negative. It's got a 5 and 10. I'm taking out a 5. Okay, so now I'm looking down. Between 6 and 10, I believe I can take out 2, and I can also take out an x. Here I can take out a negative, and I think that's all I can take out. Between 3 and 5, that's it. So I'm pulling off these factors. They look like 2x minus 1 and what, 3x minus 5. So you might want to compare and contrast that one to the previous one. I think these numbers swapped, right? Something like that. It looks very similar though, right? And the factors look very similar. One added to positive 13, the other one added to a negative 13. Okay. Then next problem. So we're still doing AC method. Same page. Okay. We have this one we want to do. Okay, so they're talking about prime polynomials now. So they say if the diagram is completed correctly, factoring by grouping must work. If a polynomial is prime, it will not be able to find numbers to fit the diagram. So a little bit to what to talk about. We're still doing this. Minus 20. Minus 20. This got to add to -2, which is my B right there. So it multiplies to AC, adds to B. 1 and 4, 2 and 12, 3 and 8, 4 and 6. I think I'm back around. So it's got to multiply to a negative. So one of these has to be negative. One of them has to be positive. And they have to add to -2. So the larger number has to be negative. Is another way to think about it. So the difference has to be 2. So where is the difference? 2 between 6 and 4, with the 6 being negative. So we're looking at these two numbers. We're breaking this thing up, and I'm going to do the box method again. My leading term is 3x squared. I'm going to break it up into a plus 4x minus 6x. And the last thing I'm writing here is a minus 8. I'm looking across here. I'm going to pull out an x. I'm looking across here. I can pull out a -2. I'm looking down here. I can pull out a 3x. And I'm looking here. I can pull out a plus 4. So this factors out into 3x plus 4, x minus 2. So this one, we can find the numbers. We can factor this thing. Okay. Now we're looking here at this one. So number 9, we want to look here at AC. So 3 times 8, now we have a positive 24. It's got to add to a -2. So I'm looking at my numbers. The factors of 24 are still the same from the previous problem. It's going to add to positive 24. Sorry, multiply to put positive 24, add to -2. So if I'm looking here, there's no way these numbers are going to add to negative numbers. But we know that they're either both positive or they're both negative. So if we look at the other set of factors that are possible, none of these numbers are going to add to -2. So this is what, -25, -14, none of these numbers are going to ever add to -2. So how do we get that? And then the quick answer is we don't. It is not factorable. They're not factorable. That's okay. I would really like to see this word right here. Prime. And we're going to use this word for a while. We're going to use the word prime. Because we can't factor these anymore at this point. So I'm kind of hinting at something, but we're not going to talk about it too much. But we'll use it for a minute. And probably not after that. So where are we going with this? I don't like what they say on this page. The trial and error, they're trying to guess and check you. Don't guess and check on this stuff. So I want to do the same thing. I want to do the AC method. I don't see a coefficient. But if I put a coefficient there, I'm doing 1 times 24 is my AC. My B, I'm going to add to is 11. So my factors of 24 are still the same. Those are my factors for positive 24. They could both be positive or they could both be negative, but we know it's adding to a positive, so they both have to be positive. So sometimes we can save a little bit of writing room if we just think about the sign on there. And the two that work are 3 and 8. So if we do I don't want to do, yeah, let's do it. x and that means the right number right there. So this is x plus 3. And wrote the wrong number. Not thinking about what I was going to write. And it was on full display. So let's look at this. This is x plus 3 I can pull out. I'm left with an x plus 8. So this factors into x plus 3, x plus 8. So I don't want to jump to any conclusions. But you might notice something there. How it factored. Okay. So now we're looking at this one. We're looking at AC. A times C. Oh, I'll grab some more paper. Is going to be 2 times a minus 3. So I'm looking at minus 6, and it has to add to B, which is minus 5. Here's 1, 6, 2, 3. So either 1, 4, on the other negative. And if they're adding to positive 5, I think I have it right here. Minus 1 and a 6. And if you think you know a shortcut for that first one, I don't know. Let's see. Let's put this into a box now. Square. Left turn is minus 3. And then in the middle, I have a minus 1x and a plus 6x. So I look across, I can pull out an x. I look across here, I can pull out a plus 3. I look out here, I can pull out a 2x. I look down here, I can pull out a minus 1. So the factors I'm getting here are 2x minus 1 and an x plus 3. Okay. So let's look maybe at this whole page again. This one factored into something like 2x minus 1, so let me just write the factor on x plus 3. And when we did our little t chart, the numbers that we found, just to remember, minus 1 and a 6, remember. So you might notice, and if you notice, and I don't want to, I'm really hesitant to tell you this little trick, right? Because so many people try to use it and they use it on the wrong thing. This works, and this works only when your A is 1. So if your A is any other number, like here it's 2, it's not going to work, right? Minus 1 and the 6 ain't matching up here. If you can see it in there, good. I don't know what to tell you. Good for you, because I'm not seeing it in there. The trick here is if this A is 1, and only if this A is 1, if it's any other number, does not work. Only do it when this A is 1. Oh man, so many people try it for other things. Only do it when the A is 1. You can jump right to the factors. So this was a positive 3. Positive 8. This will break up, if it's a quadratic, into x plus 3, x plus 8. So that is a little shortcut that you might be able to use, but only if you use it correctly. If you try to do it on something, don't you dare try to do it on something like this. I will count that wrong. Okay, so anyway, we did those two. And I guess that's what they're trying to tell you here, right? Whatever. You have to make sure your factors are correct as well, right? I guess it should go without saying, but let's say it just in case. Now, the first thing that we want to do, if it's not done already, is we want to find any GCFs between the 3 terms. So previously, you might have noticed like none of those things had greatest common factors that we could take out. There's no common factor between, what, 6 and 11. Don't have any common factor. If we have an x squared and an x and no x's, there's no x's we can take out of everything. So if we're looking at everything that was summed so far, there's no common factor that we can take out between 3 and 4, no common factor between 1. 1's already the smallest thing, right? No common factors. Now, the first step to factoring, and it's one of those things you'll probably forget because we'll get worked up with other stuff. But the first step is if you can take out a GCF, always take out a GCF. So the first step to factoring, and always, if you can take out a GCF, take out a GCF. And that is the first step. What is my GCF between 8, 20, and 28? And if you said 2, you could try that, but you'll get what? 4 and 10 and 14, and those are still even, so you could take out another 2. So if you take out the wrong number, you might notice there's still a common factor. So if you don't get the greatest common factor, sometimes you can work it down a little bit and get it smaller anyway. But you should be able to take out a 4. The GCF here is 4 between 8, 20, and 28. So we went over previously how to find these factors. So if you have to go back a video, go ahead and do that. But we've done that before. And we can take out 4 between all these things. The other thing is I have a x to the third, x squared, and the smallest power of x here, I have an x. So I can take out a 4x. If I take out a 4x, that's going to leave me with 2x. This is going to drop the power to the square. Plus 25, 45. Give you an x, this is 7, and I take the x away. So now this is what I have. Okay. So we took out a GCF. We did one step of factoring. The first step of factoring is to take out the GCF. Did you know the first thing you should do is take out your GCF? So now we're looking at this thing. We want to factor. And we're looking at this thing. So we're really concentrating just on this part. I'm probably going to do a little whammo magic trick on us. But we're looking just at this thing. And this is 3 terms. I asked myself, how do I factor 3 terms? And I go, oh, gee, you factor 3 terms by doing the AC method. And so I do the AC method. I go A times C, which is 2. It should be 13. This has to add to my B, which is 5. Alrighty then. I'm doing 1 and 14. Oh, I think it's the only factors of 14. And if it's negative, either these are negative or these are negative. If it's adding to a positive number, the smaller thing has to be negative. So I believe it'd be -2 and 7. So I'm rewriting. This is my trinomial here. Gotta rewrite my trinomial. In a box it up. I start with 2x squared. I have a plus 5. No. That becomes a -2x and a plus 7x from my magic numbers. And I have a -7. Okay. So I have my box constructed. I'm looking across my box. I can pull out 2x here. I can pull out a plus 7. I can pull out an x here, a 1x, and a -1. And so you're looking here. Oh man, I'm not gonna be able to write all this on one paper, but we'll get here. I'm looking here at my factors. And I'm pulling my factors out. I have an x -1 I have a 2x plus 7. And if you do this, you did a good job. You did a lot of hard work. But there's one thing you shouldn't forget. The first thing we did was pull out a GCF of 4x. So we're still bringing down this 4x. And this is why I'm trying to get it all on one paper. Because we're still bringing this thing down. And we still got to place it right there. So this took place of that trinomial. So we still need the 4x. So this is taking place of that thing that's underlined up there. That was my trinomial. I still have a 4x there. So always bring down your GCF. If you take a GCF out at the beginning, don't forget about him. He's got to tag along. I think we had an example like that last time. That was similar, right? There was a little tag along guy. Don't forget him. I'm pretty sure we did. There's a common factor of 4 terms. Factor using any method. Okay, so we're going to use the AC method. Probably. But the first thing, before you do anything, before you do any sort of factoring, is we want to find the greatest common factor. So we look here, do these have a greatest common factor between 6 and 13? There's going to be no constants. But if we look at the y's, and so now this looks pretty similar to the thing that I had previously. I'm concentrating on this guy, but not forgetting about that y alone out there with the 1y to the 1. He's all by himself. So so I have 1 and 36, I have 2 and 18, I have 3 and 12, and I have 4 and 9 and 6 and 6. So if I'm looking at these are going to all add to positive numbers. I want something that adds to negative numbers. So I might notice they both have to be negative for this thing to work. The next thing, I'm looking here, the two things that add to minus 13 are going to be minus 4 and 9. So I'm separating this y squared. Put it in the box. I'm separating the y into minus 4y and minus 8+6. So I'm looking down here, I can pull out 3y and a minus 2, since that leaves the negative, and this is 2y and a minus 2, since that leaves the negative. And so my true factors are 3y minus 2 and 2y minus 3. And if you can think of anything else, I want you to yell at the screen right now. And hopefully you're yelling at the screen. Why? Got to bring down that GCF I pulled out at the beginning. So that was the guy I said don't forget about. Okay, that was 11A. Now we got to do 11B. I'm looking at 6p minus. And again, this is the last page. This is student practice. I know I say it hopefully enough, but like you should be doing these on your own, right? So try them on your own and then like watch the video. You can even skip a little bit if you're like doing it right. If you're not doing it right, watch the and it will save you a headache of a time probably finding that AC during the next step, right? If we pull out 6, it'll be a lot larger numbers if we don't. Okay. And if we don't pull out a GCF in the beginning, sometimes there's ways to fix it. You can pull it out in the end if you recognize it, right? But then you also have to recognize that everything has a GCF. So we can pull out a 6 to get going. And B. Divide everything by 6. We're going to do the AC method. So we want two things that multiply to A times C, which is 1 times 2 is going to give me 2, and it's going to add 2 minus 3. So 1 and 2 are the factors of 2, and if it's a minus 3, they both have to be negative. Yeah, this is that thing. That thing I talked about. This, you can save a little bit of time if you recognize what it is. If not, go ahead and do your box method, factor by grouping, whatever you want to do. But this is going to be P minus 1, P minus 2. Because it starts with the 1, and these are my 2 factors. So I'm jumping a little bit using the shortcut. And there's one other thing. I got to bring down my 6. Don't forget your 6. Okay, so we got 2 more problems. We're almost done with this. It's a long section, but we're almost there. 9x squared minus 12x plus 4. So between 9 and 4, well, 9 is nothing but 3s, 4 is nothing but 2s. There's not going to be anything common. I think we're just going to have to go with this one and do AC method. So A times C is 9 times 4. I want 2 things that multiply to 36. We're going to add to minus 12. So 1 and 36, 2 and 18, 3 and 12. What, 4 and 9, 6 and 6. And if they're adding to a negative number, they both have to be negative. And so I'm looking at minus 6 and minus 6. Okay. So I'm looking here. I want to do 9x squared. I want to do a minus 6x or minus 6x. And the last thing I have is a plus 4. That's it. Putting this in the box. Trying to get it all up on the screen at once. Okay, I got this in the box. I'm looking down the box. I can pull out a 3x minus 2. I'm looking across the box. I can pull out a 3x minus 2. And so we have a 3x minus 2 and a 3x minus 2. And so if you wrote this, you would be correct. There's no GCF to bring down. We didn't pull out a GCF, so then that ain't a thing here. The other thing, and I guess you get to one place, the perfect square of 3x minus 2. And so we talked about perfect squares and writing them all out like this, writing them out as 2 different things when we do distribution. And we talked about that sort of pattern that they fit, right? And so hopefully that pattern, it works when we do distribution one way, but that pattern should also work the other way, right? When we do factoring. So if you notice patterns in there, there are patterns in there, I guess is what I'm trying to say, right? So if you notice them, you're probably not making it up. Although you want to make sure you are correct in the pattern that you do notice, right? It is possible to notice something that's not there, or notice something incorrectly. But here we're looking here, and you might be going, "Oh, I got to multiply 20 and 12." No, look at this again. So this one, I think they're trying to be maybe a little tricky. This is a little different than what we've had so far. They're giving it a little different because it's not in descending order. So rewrite this guy in descending order first. So now that it's in descending order, now we can do AC. So AC times 12. 36 have to add to my b term, which is 20. So I'm doing 1, 36, 2, and 18. I think this is the same number I just did. And 4 and 9 and 6 and 6. These are all my factors of 36. They got to add 20 would be 2 and 18. So I'm looking at this, boxing it up. Let's do it. I'm going to do plus 2a plus 2a. And the last thing I'm doing is plus 12. I'm looking down, I can pull out a 3, I can pull out a plus 2. I'm looking across, I can pull out an 8, I can pull out a plus 6. All right, so I look at my two factors, they look like 3a plus 2 and a plus 6. Okay, so that is the final problem that we're doing today. I will see you in class soon. Take care. Crunching the numbers.